Hello, my name is Nina Marroquin, and I work with the Office of Student of Success as an avid math tutor. And today we'll be discussing how to find the secant line and the tangent line of a function and the difference between these two. And I'll be briefly discussing the purpose of an antiderivative. So on the screen right now, you should see a function. And if you come across the words the average rate of change, this should be a key indicator of the secant line. So I want to find the average rate of change between x and x plus h. So this is my line. Oops. So in order to find the slope of this line, we have to kind of remember what we learned back in Math 50 or in college algebra of what a function is. A function is defined as something that is dependent and varies with something else. For example, y equals x plus 4. In this case, y is dependent while x is the independent. So, going back to the function that we have here, we have to remember how we found the slopes for these kind of lines. The way we find the slope is by using the function where m equals the change in y over the change in x, also known as y2 minus y1 divided by x2 minus x1. So, using the function that we just saw earlier, I'm going to do the function of f of x plus h minus the function of x divided by x plus h minus x. As you can see here, this part right here can be identified as y1 and x1. And over here is my y2 over x2. Now we can simplify this function this formula that we have right here to being f of x plus h minus f of x divided by h. This would be our secant slope. Now, if I see the words the instantaneous rate of change, I'm just curious about this point right here, that light pink point, from the beginning of this line all the way to here. And like we just learned before, we're going to have to find the change in y over the change in x, kind of like how we did for the secant line, but the only difference is that we have a limit when h approaches 0. The reason why there's a limit on this one is because we're not exactly back at the beginning of the function. Because here we're at the tangent. It's going to brush up against it but not be completely on top of it. So it's going to be something like this. That's what I'm finding right now. Now, basically we just went over how to find the slope of the secant and the tangent line. Now, about antiderivatives. The point of an antiderivative is for me to find the area that was lost from when I took the derivative, or also known as the tangent line. And that's basically it. For more information, please refer to your textbook at page 63. There's a better diagram than what I drew here. It'll go in a little bit more depth of what I just did right now. Once again, my name's Nina Marroquin. I'm an avid math tutor sponsored by the Office of Student of Success.